Hi, today I will continue with this ILS test generator. This unit is set to glide path mode here, and we can see that there is a saturation of the modulation signal. So if you look at the schematic here, we can see that we have an adjustment of the modulation depth. Okay, in glide path mode, we have this trimmer in series with these resistors. It seems that the sum of these two resistances is too high. I suspect a bad adjustment of this trimmer. So I will verify first the value of this resistor. In the second time, I will readjust this trimmer in order to have a correct modulation depth. I have measured the value of this resistor, and it is exactly 150K. So there is here a trimmer of 50K, so this value is not very large. It permits approximately 25% of adjustment. So the actual setting here corresponds to a resistance of 35 kilo ohms approximately. So this is this modulation signal in localizer mode. Okay, this is the glide path modulation. Okay, so I will try to reduce the value here of RV502. Okay, so we can see that we can decrease. Yeah, so this is the minimum gain. So I think there is something else. We can see on the scope here these two signals, 90 Hz on HJ and 150 on AK here. We can see that the amplitude changes according to the setting here. Okay, so I have calculated that we have exactly the same values here, 2.0 dB and 3.76. So it seems that we have the correct signals at the inputs here. So we can check, for example, in localizer mode. You can see that the amplitudes are approximately the same. So there is no reason that we have a saturation in a glide path mode, okay, and not in localizer mode. So I have verified the values here. Surprisingly, there is a value which is much lower in localizer here in series. There is a resistor of 68 kilo ohms instead of 150 in glide path mode. So I found this resistor on my stock 127K, 0.1%. I will connect in parallel to this one, so this will give a resistor of 68.5 kilo ohms. A few moments later, we can see that we have better results now in glide path mode. We don't have any saturation anymore. For the final test, we can connect the test generator to this glide slope receiver. So this is the antenna input, okay, which will be connected to the generator. And here we have a connector which permits to set the frequency and also to connect to the instruments. So I will use this instrument for testing the glide slope. So the glide slope corresponds to the horizontal bar here. Okay, there is a glide slope flag here. I think I have already described this unit in one of my previous videos. So it seems that we have here the IF amplifier. You can see here the transformers. Okay, so this board seems to be the demodulator board. And here there is the first bank of crystals. We should have other crystals inside this module here. On that side we can see other crystals. So we have here probably a dual frequency change using two mixers. For the test, I have connected this light path deviation indicator to the glide slope receiver here. The glide slope receiver frequency is set to 334.7 MHz. This corresponds to a localizer frequency of 108.1 MHz. It is the setting of the generator here. So we can see that the flag is activated here. If I change the mode of the generator from glide path to localizer, for example, the flag appears. Currently the DDM is set to 0. That means that the amplitude of the 90 Hz signal is identical to the amplitude of the 150 Hz signal. Okay, so let's change this setting, for example, 2 dB. Okay, 3.76 dB. Okay, and on the other position, up. It is also possible to have a variable setting here. That's all for today. Thank you for watching. See you next time for another video. Bye bye.